But without any further ado, I would like to invite Bryan Reimer up from MIT to tell us about what's going on there. Thank you, Bryan.
Good afternoon, everyone. In my talk today, engineering safer cars in a technology-rich, fast-paced environment where automation is changing our relationship. And we could sit here all day and talk about automation. We can talk about older drivers, but we're talking about a system change in our transportation infrastructure from where we are primarily driving a car to car sharing, other mobility patterns that are going to continue to evolve over the coming years. So if we think of the vehicle, we can think of a vehicle that is going to have bigger screens. And I love Tesla's picture here because the reality is screens are increasing in the car. We're also going to be bringing more and more things into the car, whether it's the smartphone of today or some other personalized technology of tomorrow. As much as we'd like to engineer that out of the car, the reality is there is going to be a place for that looking forward. The amount of information we're surrounded with, I hate to say it, I wish it was going to shrink. I wish my phone would sometimes disappear with my email box, but the information flow, it's only going to get worse until some of us learn to shut that off. And maybe we'll defeat our social pressure to communicate at some point in the future. Now, we could talk about older adults. I do come from a lab where we study older adults in quite depth. The reality is there are going to be more older adults on the road, but if we want to build truly safer vehicles, we have to look at this from a holistic perspective. We have to look at systems from an infotainment, safety perspective that are there to help everyone along the way. So if I can build a car that'll help the older adult get from point A to point B safely, how do I ensure that the younger adult, the inexperienced driver, is going to benefit just as much from that? So I have a really hard problem. The old man was not going to buy the old man's car, and neither was his kids, and let's get out of that discussion. So how do we build a car that's really universally acceptable? Automation. Google in the news yesterday. Yeah. I'm not so sure I'm getting into the car driving on the local roads of Boston without a steering wheel. You know, in Southern California where the weather is predictable and they don't have as many potholes, maybe. But I'll tell you what, one New England winter, I can guarantee you no matter how good the sensing technology is, we can't even keep our hubs straight. So, no go. There will be automation in my future. Maybe it's in the highway, maybe it's in stop and go traffic. It's going to change my relationship with the car. But that steering wheel, it's going to stay there for a while because I will remain the central responsible party for the operation of that vehicle for a good long time. Anybody willing to get into an airplane without a pilot up there today? Anybody? Taking one, nope, no one? So if we think about that model, we may not be in the same control space, but we are the responsible party. And that brings up inexperience. And this is probably, we talk about a lot of little issues in automation. How we're going to transition control back and forth to the vehicle, it's a little issue. This is one of the big ones. We are going to create fundamentally a new class of inexperienced drivers. As VMT, vehicles miles traveled for the non-automotive folks here, diverges from, I'll call it VMD, vehicles miles driven, because you're traveling in the driver's seat, but you're not fundamentally driving. We're not going to have the experiential knowledge on how to drive anymore. Well, the FAA has admitted in the last few years that pilots don't have the same experience they've had in the aircraft in the past, and they've fundamentally accepted that pilot skill is eroding at the expense of automation. This is where we have a baseball bat to motivate training and compliance. The life of your passengers, the life of yourself, and in many situations there. We look at the Miracle on the Hudson and case study after case study. It's where the pilot gets involved and bails out the automation, and that's why many of us want that pilot there. So when we think of inexperienced drivers today, we think of young adults. When we think about inexperienced drivers tomorrow, we're thinking about all of us because our experience level is about to shift. I'm no longer going to drive on the highway thanks to some of the newer GM vehicles, or no longer in traffic thanks to some new Ford vehicles. It's going to change my ability to react when I fundamentally have to have my hands on the wheel. And we don't know how to predict that yet. And the question is, will we figure that out before it's too late? So, the challenge for safety professionals, regulators, manufacturers, how to develop safer vehicles that provide drivers with enjoyable, easy to access information while using automotive and other safety technologies to help maximize driver focus on the road. It's a cohesive system. How do we use the automation to support the driver? How do we leave the driver in the role to take over and oversee the automation if needed? It took the aviation industry years to figure out that we don't want to replace the pilot. We want to support the pilot. We want to support the driver. They're the responsible party. So this is going to require a better understanding of how drivers are managing information in the vehicle, how they manage this information under different operating contexts, in the highway, in the city, under automated driving, under non-automated driving, and everything in between. So I bring this back to the Yertz-Dodson principles, and for those of you who've seen me talk before, I've been using this graphic for some time now. And the reason is because it is the fundamental underpinning of the fight we have with information in the vehicle. And the Yertz-Dodson law of arousal says we need a fundamentally acceptable level of arousal, workload, stress to perform well. Too little, I fall asleep, I can't maintain attention on the road. So, automated feature, but you can figure out what happens. Now, too much workload, stress, distraction. What do? Text, talk to someone, do things. We need help finding an optimal balance in the middle. And many of us can think about our own lives, from our desk to our home to our workplace. Everywhere, we're managing information in different directions. So the environment today, workload, stress, distraction, trying to do too much. Their workload tomorrow, automation, pulling it away. And we are going to fight like this, tooth and nail, back and forth for some time to come. Until we fundamentally realize that what we need to do is holistically support the driver in that realm of trying to support their focus when they need it. So let's go to a couple different pieces. Some other areas we talked about earlier, IHS's crash safety ratings that came out today. Great, wonderful. Engineering test of forward collision mitigation systems, active emergency braking systems that IHS would like to call it. Engineering test. The question is, when you look at some of the HILDI data or some of the crash data, it starts to predict when these systems are working and when they're not working. There's some indistinguishable mismatches. Forward collision mitigation systems are a technology that no older adult should be on the road without. Now, they may not work perfectly, but the reality is if you hit something at a few less G's, the reality is you're going to walk away from that collision. Now, lane departure systems. We heard earlier, the potential is huge. They're not showing up here in the HILDI data as saving lives. Why not? How do we figure out this disconnect? How do we understand what the engineering test needs to look like when we as humans get in the loop? Because we mess up the automation, and we're going to continue to mess up that automation until we've learned how to use it effectively. And we learn to optimize that automation to support our efforts. Some of our efforts here, they're trying to build an understanding of the bridge between these two data sources and trying to look to naturalistic and FOT data that doesn't exist today and anywhere in the world outside of Europe to try to support that understanding. Just starting some of this work. Cognitive-oriented interfaces. Voice interfaces have been promoted as a hands-free, eyes-free way of communicating with your vehicle. Anybody heard that slogan? Anybody? Yeah. Question is, how demanding are these things? So, one of the studies we've done here, we've done some more lately, looking at developing, understanding a comprehensive view of how drivers are managing information flow to the voice interface in the vehicle. And this is a series of 3 studies that was actually done over 2 years in Lincoln MKS, which started all the way back in 2011, trying to understand holistically how drivers are managing information in the vehicle. And the results were quite surprising. Our hypotheses, as I said earlier, cognitively oriented interfaces, impart demand on the driver. These aren't cognitive interfaces. Here's the eyes off the road time for different interactions. These are multimodal or mixed mode interfaces that pull on drivers' attention in a variety of different ways. So if you looked at the dotted line here, the slash line going across, that's NHTSA's new 12-second guideline. 12 seconds of off-road glance time during a task. I have a laugh here in the front. Do you notice a problem here? Well, here's the good news. This is field data. NHTSA's defined it in simulation. Well, I can tell you that some of these bars are going to come down in the simulator. But Houston, in a 110-second activity of entering a navigation address, 2 studies, different populations, 60 people, little different characteristics in the 2 studies. There's about 30 seconds of off-road time there, and your 85th percentile, the passing mark is the little bar above the bars. A little horizontal line above. We got a little problem here. We got a policy disconnect. So, unexpected and unintended consequences? We never thought we'd be able to field this work. We figured the speech recognizers in the vehicle would be so bad that people wouldn't be able to communicate with it effectively, that we'd lose half our population. Nah, only 6 of about 193 people had problems communicating with the speech system. We're doing better than we ever thought there. Voice command interfaces show advantages over visual manual interfaces in some situations. In other situations, they have unintended costs. On the positive side, voice command systems had far lower cognitive demands than we ever expected. They're not cognitively oriented interfaces. They're mixed mode interfaces. As I showed earlier, though, they do draw on visual attention quite extensively. Well, this is one set of studies and one set of vehicles, and some other data that we're working through right now pretty much says this is quite generalizable with pluses and minuses depending on how the manufacturers have adapted the vehicles. But by and large, we are dealing with a new world of mixed mode interfaces as we, as humans, through all of our sensual channels, communicate with information in front of us. Let's talk about one other thing. Let's get out of the driving realm and the transportation embedded system realm for a minute. Talk about a new technology called Google Glass. Sounds like a fun technology. Maybe there's something we can learn from it. So here, most of the work that I do is among greater Boston area participants. We recruit people from outside the MIT campus. But Google Glass has such a complex mental model associated with the technology that we looked at MIT students for a change, because we wanted to understand that if someone could understand this interface and could effectively work well with this interface, what are the advantages and disadvantages of this interface? So we looked at navigation, destination entry, where you spoke a whole address into the system, say 77 Massachusetts Avenue for the front door of MIT, into Google Glass, into the driver mode of a Samsung Galaxy smartphone, and then we asked them to enter it by hand with that phone. And through the process, we used what's called the detection response task, which is basically a red light blinking in front of the driver, and look at the reaction time to that light. And the results are quite surprising, because everybody has heard in the news, well, Google Glass must be a disaster in terms of the safety on the road. Well, the reality is maybe there are some differences we need to think about. So here on the left, task time. Anybody notice anything there? Google Glass is quite efficient. Shorter interaction. Seems like a positive. Again, if you can understand it, if you can deal with the information on your head, but maybe we can learn something there. Voice phone interfaces, faster than typing that address. Look at the workload values from the NASA TLX and a 0 to 10 global workload scale. Again, floating right on up. Well, we look at the disruption in our ability to respond to a brake light task. Yep, there is a little increase in misses with Google Glass over the voice interface, but we turn the disruption in alone, quite synergistic. What can we learn from interaction modalities? Because there are benefits and drawbacks to various ways of communicating with information. So it's a summary comments. The task structure of Google Glass is something we may not want to ignore. Maybe it's not perfect on my head. Maybe we want it on a heads-up display, but it's not something we want to ignore. Modern voice command interfaces are not eyes-free ways of communicating with your vehicle. They have incredibly high visual demands. We talk, we look. We put a list in front of somebody. We search on it. Maybe that's the advantage of the interfaces, that the list reduces the cognitive demands. Now, there are advantages of these interfaces. We want these interfaces in my vehicle, but how do we begin to understand how to optimize it? It really argues that we need a holistic view of the demands placed upon the driver in any given situation, and we need to work on using technologies to support driver focus. How do we move away from distraction, specific populations, and how do we move to technology development that supports driver attention in really context-relevant ways? Thank you.